Về cái giả lên đây từ đâu?
Chưa biết toàn nói rồi.
Có thể học được thôi nha, chúng ta ngủ. Này không có mở. Bắt không đâm.
Con tim chưa bao giờ recording.
Dr. Lu?
Yes.
Hi.
Yeah.
Nice to hear
Hello,
you.
Professor Wagner. Okay. We will start in 5 minutes.
Everything is okay. Everything is fine. Can we try to share the screen?
Yeah. Yes. I will allow you to share the screen. Okay.
Okay.
Yeah. Yeah.
So I save the. So let me see where my presentation is.
Yeah.
Should be. Meeting notification. Where's my screen? That's a problem. Here's my presentation. Do you see my screen now? So my presentation?
Okay, I will stop. Yes.
Do you see my presentation?
Yes, I can see.
You can see, and
You can put a full screen. Okay, that's right.
full screen.
Yes,
okay.
that is okay now.
Okay,
Yeah.
okay. So I let it like it is, and we wait when you open the conference. Yes, and then I give you the
Okay.
presentation.
Around 5
We
minutes.
have time. We
Right.
have time.
We will start. Yeah.
Okay. Is everything okay in Vietnam, in Ho Chi Minh, or there are some problems with COVID?
Yeah.
I understand. Yes.
Yeah, it's not okay. Yeah, Professor Wagner, we have some problem with the COVID. Right.
Okay.
And everything is locked down now.
It's locked down. Okay.
Yes, and even the university. Now we sit to the online.
It's also forbidden to travel.
Restriction. Just only for
to travel around in the country.
Yeah, well, just in the south of Vietnam, and some big city. Yeah, in the south of Vietnam, in the half of the country.
Okay.
Yeah.
And in Hanoi is allowed to travel.
Hanoi also have problem, but it's not serious in Ho Chi Minh City and also in Bình Dương. Okay.
Okay.
We are in the center of the storm.
Okay. Yeah. So today we have only my presentation, or do you also give a presentation?
No, only your presentation. Okay. Yeah.
So because at 11 German time, that means 4 o'clock your time, we have I have the next meeting. So but 1 hour I think is
1 hour is, I think it's okay, right? For the honors. Participant. Yeah.
Yes, we have a lot of participants, I see.
Yeah.
That's fine.
Yeah.
Good job. Good job you do.
We are waiting for some more audience.
Yeah, sure.
Yeah. Okay. Also, that some of my colleagues in the other university.
Yes.
Okay.
I understand that.
Professor Bùi Xuân Thành from Ho Chi Minh University of Science of Technology.
Okay.
Oh,
yeah.
Nice to meet you. Yeah.
Okay.
Hello, nice to meet you.
We meet in some of the conference 2 years ago, right?
Yes, that's right.
Yeah.
Long time ago.
Yeah. Okay. Yeah. And Professor Mạnh Hà from Saigon University.
Hello.
Yeah.
Hello, nice to meet you.
Yes. Yeah, my camera is some issue, so I cannot show my cameras.
No problem. No problem.
Okay. Yeah. And Dr. Nguyễn Đình Vượng from Institute of the Hydraulic Engineering.
Okay.
Yes. In the Southern Campus.
Okay.
Yeah.
Okay.
Let's see.
And the new colleague is with you in your team actually?
Yes, and some
from Kyoto University.
Yes, and also the network, a different university, and also some of the student.
Okay.
Yes, I'm also a student.
Okay. So I give a short overview
to I'm not sure that.
Okay.
I'm not sure that. Could you introduce yourself, Professor Hạnh Phúc? It's not here. Okay.
Okay.
Yeah. And not sure that Professor Việt Anh can participate today or not?
Oh, I hope so.
Yeah. Yesterday I informed him about this, and he said that he will join. Yeah.
But he is very busy, I know. So maybe
Yeah.
he has other duties.
Okay. Yeah.
Today our students have their written exam.
Yes, and they will finish around 3:30. Okay.
Okay.
Vietnam time, and
Okay.
Dr. Đoàn Văn Tuấn, right, from Ho Chi Minh University of Technology also.
Okay. Hello to you. Hello.
Yeah. Dr. Dũng Nguyễn, I'm not sure that where he's from. Okay, that's
I'm from home.
Yes, and also our student,
Everyone.
Nguyễn Tuấn Anh, is also that business student in our university.
Hello.
Okay.
Nice to meet you.
In the field of water technologies. Okay.
Okay.
Yeah. He also studied master in sustainable urban development before. Okay.
Okay.
Yeah.
Hello, Professor.
Hello, nice to meet you.
Yeah.
Best wishes to Vietnam.
Yeah. And some of the upcoming student for the this intake.
Okay.
Okay. Yeah.
Oh, I understand. We need some more students, but I'm happy to have nearly around about 10 students.
Yeah.
That's very good.
Okay.
Very good job.
Yeah.
Very good. In this time, it's very good.
Yes. Okay. Yeah. And on participant, if you have any question, you can put in the chat box. Okay.
Yes.
And I will handle it to Professor Wagner after the seminar.
Yes, you can send it to me and I will answer it.
Yeah.
So I think also Jana Trippel will participate when she is ready with the written exam.
Yes, of course. Yeah. And they will.
Okay.
Thought they will come later.
Now we are 44 participants, I see.
Yeah. And also Mr. Vũ Phá Hải. I guess he's expert in the field of operation of wastewater treatment system design. Okay.
Okay. Hi everybody. My name is Hải. Okay.
Yeah. Why don't you introduce about yourself?
Okay. I work for Rintech, your stock company.
Yeah.
A company special in water and wastewater treatment.
Yeah.
Okay. And I also have some the wastewater recycle in my project.
Yeah.
Okay. Water reuse.
Yeah. Water reuse. Okay.
And now I can see the experience of Professor Nguyễn Việt Anh from Hà Nội University of Civil Engineering. Okay.
Not yet. Not yet.
Good afternoon.
Yeah.
Good
everybody.
Afternoon.
Good afternoon, Professor Wagner.
Professor, nice to see you.
Okay.
Nice to see you.
Right.
How is it in Hanoi?
We are in the social distancing, and maybe it will be extended.
Okay.
But we have to work in different conditions.
Yeah.
Okay. I am at home in my home office since nearly 2 years. So.
Very good.
Unfortunately, next semester we also give online. Not possible to go to the university. So
really,
yeah. Really. And we waiting for the next wave. It's the fourth wave for us. Let's see what happens.
Yeah.
Yes.
And all of your staff got already 2 doses of vaccine, or?
I have 2 doses.
Okay.
Yes. My son Maximilian, you know him?
Yeah.
He is in New York at New York University, and they give the lectures in the university. It's not a problem. All students are in the university, and the lecture is live.
Wow. Face to face.
Face to face. Yes.
Yeah.
That is different.
Yeah.
So,
You never know.
So, Dr. Lu, I think we'll start.
Yeah. We will start. Okay. Yeah. And good afternoon, everyone. And thank you very much for your participation today. So that I sum up the.
49 participants.
Yeah, right. Okay. And also that today I would like to introduce the seminar of Professor Martin Wagner. Okay. And he's the director of the master program in the water technology review and management at the Vietnamese German University. And he's also the professor in the Department of the Civil and Environmental Engineering at the Technical University of Darmstadt, Germany. And also he is the director of the Water Resource Institute of the Technical University of Darmstadt. In the 2020, we also set up the cooperation between the Vietnamese German University and the Technical University of Darmstadt to open the master program in the water technology and reuse in Ho Chi Minh City. Okay, and I'm very happy to work with here during last 2 years. Okay.
Oh,
yeah. Today he would like to introduce about the seminar about the water review in Germany, and also some of the learning and experience. Okay, so please welcome Professor Wagner. Yeah.
Thank you very much, Dr. Lu, for your kind introduction. I'm happy that we are a lot of interesting people here to hear my presentation, and I'm very happy to see my old colleague, Professor Wet An from University of Civil Engineering. I work with him since years. We do some research projects. He was in Germany at our institute. I was in his institute. And I hope we will have a good cooperation with Hanoi University of Civil Engineering and also VGU and all the colleagues. Yes, ladies and gentlemen, thanks that you are with us today. I will start with a short introduction of the study course Water Tech. That means water technology, water reuse, and water management. Share my slides. The course is in Ho Chi Minh City at Vietnamese German University. There are 4 semesters and 120 CPs, credit points. And I hope we will get 25 to 30 students, and our special focus is water reuse. The water reuse in municipal and industrial wastewater treatment plants is a unique selling point for this course. Here you see a short overview of the 4 semesters. In first semester, we start with some fundamentals like water chemistry or legal aspects of water management, GIS and water management, English scientific writing, and spatial planning. And in the second semester, that will be in summer semester, we start with economics of infrastructure. We start with river basin management, and Dr. Lu gave his lab course, water analysis, and my colleagues Engelhardt and Wagner start with their course, water treatment processes. And it is also necessary to hear something about waste technology and the fundamentals of waste technology. Professor Schebeck will do this course. So in the third semesters, we have two specializations. One is water and wastewater, and the other is river management. I will start with river management. Here, the students can hear hydromechanics and the distribution network for water supply lines, for example. You can hear something about flood management, river engineering, hydraulic structures and modeling, and also modeling details of hydro systems. The specialization water and wastewater start with the course drinking water. I give the course municipal wastewater and reuse. Professor Engelhardt started with industrial wastewater and reuse. A former PhD student of me speaks, and she is now at a German consultant company. She speaks about planning, construction of wastewater treatment plants, and last not but least, the student can hear in my course the operation of wastewater treatment plants. We will start an interdisciplinary project. Here, Professor Dr. Lu and I are responsible for this interdisciplinary project. The students will learn something about planning of water works or wastewater treatment plants on special examples. And in the fourth semester, the student can write their master thesis. The master thesis they can do in Vietnam, but they also can do it in Germany. And I hope a lot of people can come to Germany. So that is in very short time the concept of our study course. Here you see the different CPs. The basics courses are 24 CPs, the interdisciplinary courses 12 CPs, the main courses altogether 30 CPs. Then comes the specialization, one, water and wastewater, and the other specialization is a river management, 30 CPs, and 24 CPs for the master thesis according to the specification. Coming to the first and second semester, what we want to show is a development of relevant contents for the later specifications or specializations, creating of a broad knowledge base. Students learn scientific work and discussion, legal aspects of water management, also scientific writing and presentations in English language. Here, the structure of the study program in the third semester, the two specialization, I don't repeat it. You see it here, wastewater specialization and river management specialization. Coming to the main focus, the reuse selling point. What you see here is a water reuse plant in Australia. And I am of the opinion that no other university in Asia teaches this topic to the same extent, with the exception of the colleagues in Singapore. And we have a slogan created, or create a slogan, where we are of the opinion that water reuse is our future. The students, when they will be ready with the study, they are able to work scientifically on their own responsibility. They will find creative technological solutions for different water problems. They can have experience in sustainable development of urban, industrial, and also rural areas. And it is possible for the students to have employment in Vietnam itself or in Southeast Asia and internationally, for example, in Germany. A lot of German companies are interested in the, Vietnamese students because of their language skills. That means Vietnamese and also English. And they are happy to have Vietnamese students in their companies for selling products, for example, or give some consultancy. Where the students can be work, governmental and non-governmental organizations in the private sectors, companies, industries, associations, and also consultancies, and in research institutions like our university. Master degree is not the latest degree at universities, the doctor degree. And actually, my colleague, Professor Linke, he's also teaching at VGU in development. He has a lot of master students which are now working on their PhD, especially in Germany. Okay, that's a short overview of the study course in Vietnam at VGU. And now I want to show you what you can work when you are ready with your study. And I will show it to you in on the example of the water reuse in industrial parks. I give you some aspects, experiences from my side. The presentation was done by Mrs. Jana Trüppel. She's also working for me. She's a Master of Science in Environmental Engineering, and she is responsible for all organization topics of the study course. Coming to a short introduction, yes, I'm sure, and you know that Southeast Asia belongs to the world's fastest growing regions in cities and also industrial areas. The urbanization has a huge influence on new or on the expansion of industrial parks, locations which are typical for Southeast Asia region, for example, China, or also in Vietnam. I do a research project together with Professor Wirth about water reuse in industrial parks. And we know that it is sometimes a water shortage in industry parks, and so the development of the industry parks are hindered because they have water requirements with respect to water quality and also to quantity, and the water is not here to produce tap water or cooling water or water for irrigation and for production water. And so one possibility could be the reuse of the water. Okay, in the time of or in the times of climate change, and we within these times, the shortage of the resources and the increasing importance of environmentalism is important to ensure a sustainable water supply to enable new developments in all the countries in Southeast Asia. And here you see a figure what happens when there is not enough water, when there is not enough water in our rivers and in our seas. We need a sustainable water management and also water reuse concept for industry parks, and they become more and more of importance because the reducing of high water consumption from natural resources like groundwater, river water is absolutely necessary. the opportunity to enable industrial development is in water stress regions also very, very necessary. And the water stressed region are in regions in Southeast Asia. I have here an example from the People's Republic of China, and on the left map you see China, and in red color you see the water stress, which is in red color, extremely high. And you see a great part of China, which is a very big country, they have extremely high water stress. And you see on the right map industrial park locations. And the industrial parks are also in regions with water stress, especially in the region of Shanghai, with respect to the northern part of China. You see a lot of industrial parks, and they need clean water for the production and so on. We together developed a concept together with our colleagues in Vietnam, in Shanghai, Tongji University, and also Qingdao Technological University, Professor B, together with Professor Viet An from Hanoi, and also with some help of the colleagues at Nanyang University in Singapore. We developed the concept, industrial wastewater management concept, with a focus on reuse, and you see the abbreviations IWMC to reuse. That includes first sustainable treatment of the wastewater in the industrial parks, and they provide reuse water for different infrastructure purposes by a water reuse plant. So, and here you see the different possibilities for reused water. Starting with processed water, we need cooling water in the industrial parks. We need irrigation water, so firefighters need water. And in Southeast Asia, it's necessary to clean the roads, to stop the dust, for examples. And last but not least, you can use treated wastewater for toilet flushing. So coming to our concept, on the right-hand side, you see very dirty water from an industrial park. And on the right-hand side, you can see how that it is possible to clean it to such an extent that's very good water for reuse purposes, irrigation, street cleaning, and so on. But it's also possible for parks. Yes, you see here a golf course, and you can provide reused water for a lot of infrastructure purposes, golf courses, park irrigation of agriculture areas, for example. That is also possible with our concept. And I will show you the possibilities. So we started with the development of our concept in investigations in industrial parks in Germany, in China, and also in Vietnam. That was in the year 2017. And the idea was to learn from the existing industrial parks for new ones. And on the right-hand side, you see a big industrial parks in Germany. You see in the middle, Shanghai Chemical Industry Park in China, and the Amata Industrial Park in Vietnam. In every park, we are looking to 3 topics. For example, actual water supply situation, we start the actual wastewater treatment system in the park and the possibilities of water reuse. And what we learn from the visits in the different parks, I think we visited more than 10 parks, that the wastewater, the water and wastewater system looks like this. That is possible in Germany, in Vietnam, but also in China. On the top, you see the water supply. There is a central water treatment plant, and the tap water or water in another quality is pumped to the production plants. Here in this park, the model park, only with 6 production plants. They use the water for different purposes, yes, and maybe after treatment, the wastewater flows into a main sewer, and from the main sewer into the wastewater treatment plant, where the water is treated and is then pumped into a river. Another example, and that we find in China, in the Shanghai Chemical Industry Park. On the top, you see is a centralized water treatment plant to produce a good water quality. And you see the different production plants, but every production plant pumped the wastewater into the central wastewater treatment plant. And when there's, for example, an accident during the production process, when there are poisoned wastewater treatment plant, for example, the operator of the central wastewater treatment plant can close the valve, and there is no problem for the wastewater treatment plant, and all other production plants can produce their product. And after the problem is solved in the production plant where the accident happens, they can start production and can start operation. Okay, that is a possibility that is existing. And now from this on, we have an idea for the water reuse approach here in this system. First of all, we have the central wastewater treatment plant, central water treatment plant, excuse me, to produce tap water. The production plants pump their wastewater into the central wastewater treatment plant, and a part of the treated wastewater is pumped into the river, for example. But another part we pump to the water reuse plant. And for example, after the headworks, screens, and so on, sand traps, we have an equalization tank, and then we treat biologically the wastewater. We have UV disinfection, and when it is necessary, chlorine dosing. And then we can use this water for cooling aspects, for street cleaning, for the firefighters or toilet flushing, and for the irrigation. A little bit complicatedly is the other approach, where we have the production plants when they have different sewers to the wastewater treatment plant, but here we can treat the wastewater in different lines. For example, for nitrification, denitrification process, that means that we reduce the concentration of nitrogen in the water. And when we have very high concentrated salty water, for example, then it is possible, because the flows are very small, then we can, for example, incinerate the wastewater. That happens in the Shanghai Chemical Engineering Park. But also this water we can use for reuse purposes in the water reuse plant for the different aspects. We focusing on the water reuse approach number 2, which I shown it actually here. And we create now in model industry park not only with 6 production plants, but we use 19 exemplary production plant from non-food production, including canteen, sanitary, wastewater. And here on the left-hand side, you see the different production lines, for example, production of H2O, polystyrene, chlorine, fruit juice, maize starch, paper, ethanol, batteries, potatoes, and so on and so on. We uses a characterization of the wastewater flows for a treatment in different treatment tracks or lines in the centralized wastewater treatment plant in the park. We separated it into categories according to their carbon, nitrogen, and phosphorus concentration. And for the future students, that is necessary to treat the wastewater in a good way. So, and here is, for example, the production of the reuse water fit for purpose. Yes, you see on the left-hand side on the bottom the different production plants, number 4, number 12, number 13, and we treat it in this way, and so on and so on. And in the middle, the green part is a water reuse for the different purposes I showed you before. We started with the aerobic biological treatment. That is very common in all our countries, in Vietnam, in Germany. Important is the concentration of organic material, nitrogen and phosphorus. We have very high concentrated wastewater with respect to organic material. Think of breweries, yes, that is very high organic loaded wastewater, and we use a special step to treat it. And for example, because we have a high concentration of solids in the wastewater, we need a sedimentation step, and after that, we can treat it in a good way. And I speak in some in other slices about the incineration of very high concentrated salty wastewater. The treated wastewater from different lines is pumped into the water reuse plant, where we produces reuse water. Yeah, after filtration, an equalization tank, we can use ultraviolet UV light for disinfection, and when it is necessary, we can dose chlorine. So now we want to have a look how many wastewater from the production plants we can reuse. For the evaluation, we required a reuse water application, and we developed all together, the German side, the Vietnamese side, and also Chinese side, an industrial park reuse factor, IPRF. And that is not, the definition is the required reuse water flow compared to the whole wastewater inflow to the centralized wastewater treatment plant. And that was what I show you here. That is research in the area of wastewater treatment and the production of reuse water. And that you will learn when you study at our university, but also when you studied at the University of Professor Wagner. The IPRF consists of the production plant reuse factor. That means the reuse water is used for the production site, inside the production site. And we have another factor, that's the infrastructure reuse factor. That means the reused water is used for irrigation, for toilet flushing, for street cleaning, for the firefighters, and so on. Okay, IRF is an infrastructure reuse water flow compared to the whole wastewater inflow to a centralized wastewater treatment plant. Left-hand side in the next slide, you see our model industry park with the different productions sites. We know from this production plant the wastewater effluents in cubic meter per ton of product. That is based on literature data analysis. We know the production capacities, ton of product per year, and we know the sanitary and canteen wastewater flow, so that we know the whole wastewater inflow into the centralized wastewater treatment plant. And here you see the calculations, for example, and I want to show you only the sum. Per day, there is a flow, a wastewater flow of nearly 95,000 cubic meters. That is really a big plant, for example. So now we're coming to the determination of the required reuse water's flow. What we need to calculate the water flow of the reuse water is the size of the green spaces. That means the reuse water demand for irrigation. The size of the road spaces, because reuse water we need, the demand we need for the street cleaning. We also need the number of employees, because reuse water demand for sanitary water, for example, toilet flushing, that is necessary when we want to use reuse water. And also important is the cooling water demand for the production plants. Reuse water we need for the cooling towers for make-up water. So starting with greens, and we know that around about 20% of a park, and here's an example of a park with 823 hectares, green spaces are around 20%, the road space is 9%, and we know from this example that 35,000 employees are working in the industrial park. So then we can calculate the different required reuse water flows. We know that for toilet flushing we need around about 40 liters per employee per day. Street cleaning 2.5 liters per square meter of street per day. The irrigation of green space 2 liters roundabout per square meter per day, and so on and so on. But in sum, the required reuse water flow is roundabout 13,500 cubic meter per day. And now we can calculate the IEF. Yes, we have 13,500 infrastructure reuse water demand. We have 49,000 cubic meter per day of wastewater inflow into the centralized wastewater treatment plant. And that means we can reuse nearly 15% of the water for different reuse water. And that is a lot of water we don't need to produce from groundwater, from our rivers to a top quality. Why we have to use very good drinking water for toilet flushing? That's not good. I am of that opinion, but we can produce reuse water from our wastewater treatment plant. May vary by using other case studies. Yes, you know. What is the impact of to calculate IEF, the size of the production plant, the type of the production plant, that you have to know when you will start to calculate the IEF. Yeah. So coming to conclusion, reaching sustainability by our concept. Sustainability requirements can be reached because we are saving water from natural resources. We can optimize water reuse opportunities by an efficient treatment of wastewater and produce reuse water fit for purpose. Yes, we can produce in different lines water fit for purpose, for example, for toilet flushing, for street cleaning, or for irrigation. We need different qualities of reuse water, and that we mean when you speak of fit for purpose. We can optimize the water reuse when we evaluate the reuse potential via our IEF. And that is also interesting. We have positive effects on the reduction of the carbon footprint. That is, and so, ladies and gentlemen, I am at the end of my presentation, and thank you for your attention. And I am open for questions. You also can send me an email. Dr. Lu has my email address, and I am happy to answer your question. Thank you very much.
Yeah. Thank you very much for your presentation. Very nice, Professor Wagner. Okay, yeah. And
so hopefully
you have any question? Yeah. If you have any question, you can unmute yourself, right? Okay, and yes, Dr. Dawanton. Okay, you can unmute. Yes, press unmute. Yeah.
Give me a minute. Yeah.
Okay.
Professor Wagner, I have one question. So in Vietnam, industrial water, wastewater, normally treatment process is not enough. When we discharge into the canal or collecting system, surface water, so we normally have many problems like heavy metals still remaining, even though it is a trace amount, but it's there. First one is heavy metal. The second one is xenobiotic. Xenobiotic in something. Xenobiotic is some problem with the organic compound that very difficult to decompose, biological or chemically decompose in the nature. So yes. To reuse such industrial wastewater is very critical for us at the moment. So from your research, from your studies, and you could suggest us how we can deal with that problem, because now we have many companies, factories, but finally they discharge into a kind of wastewater treatment system of in that kind of industrial zone. But heavy metal is still a problem. Xenobiotic is a problem. And last but not least, but the virus these days and treatment of bacteria or pathogens is still concerning. And please give us the kind of
I understand. And
yeah,
I understand, and you are right.
Yeah.
But in industrial parks, we have a lot of not so polluted wastewater. For example, coming from breweries. Brewers have no problem with heavy metals or other contents. Or you have food production, fish production, meat, and so on. And when you separate in a product in an industrial park, that wastewater, and that are the high flows, because they need a lot of water for the production, for cleaning, for example, yes, then you can reuse this water. I show you when you have very salty water that is not possible to treat, costs a lot of money. For example, that means you have to incinerate it, yes, and that's the same problem. And when you have metal production with very high concentrations of heavy metals, so first step, heavy metals, you don't bring it into the wastewater. The first step on the source, you have to reduce the concentration of heavy metal in the water. Yeah, And it's a long process. We do in Germany this process too. It's a long time, but I am of the opinion we have to start. And after that, we see. Yeah, you have right. Yes, you have right. But when you say, so we do nothing, yeah, then you have no success with other purposes. And the inhabitants in the cities, they need water, more and more water, yeah, because park irrigation, street cleaning, and so on and so on. And why you will get the water when the water quality of your raw water is not very good. Yes, I've seen it in Vietnam. I've seen it in other countries worldwide. The quality of the water is of the raw water for the production of drinking water is very often more bad compared to the wastewater treatment plant in the outlet. Yeah.
Yeah.
Okay.
Thank
you for your comment. Yeah. Thanks.
Yeah.
Thank you, Professor. Yeah.
So next question, please. Possible. Professor Việt Anh, Professor Bùi Xuân Thanh, if you have any question, Professor Hồng Quân, yeah.
Okay, thank you for giving me. I would like to raise one comment, and that would also for brainstorming after a very informative presentation of Professor Wagner. We all know that wastewater use is very good. And as Professor mentioned, this is our future. But to bring it to the practice, we need to overcome some barriers. Somebody just mentioned some barriers, characteristics of the wastewater. And of course, we have to select the right wastewater for right purposes of the reuse. I think from the perspectives of the enterprises, there are some driving forces, and if we have driving forces suitable for them, then we can make the wastewater reuse realized. First is cost benefit. That in the presentation you see, we have to come up with the benefit which should be more than cost invested, and for that, the price of water and wastewater should be comparable. When the price of water is even cheaper, when you take water from far and bring and treat it, and even still cheaper than the wastewater, then it's not the driving force, not attractive. Yes. But the price of water is increasing, and in some areas, simply no water, then this is a very strong driving force in many cases. And of course, from case to case, we cannot copy, but very localized driving force. Second is a standard, the policy, the enforcement, and also the control of the government. When we reuse wastewater for industry, we have less problems than we spray water to the golf course or to the park. Then we have contamination, we have the contacts, we have the virus, etc. So the Ministry of Health, the Health Protection Agency also should put hands in this. So legal framework, I think it is very good time in Vietnam when we are talking about this topic, because Vietnam has recently issued a new environmental law in 2020. And the ministry is drafting now the decree to implement that law. And in the decree, it clearly states that the government is encouraging to reuse wastewater in national parks. And the decree number 82 of the Ministry of Planning Investment mentioned that we are going to establish the eco-industrial park. And there are some criteria, including wastewater reuse in industrial park. And the park is recognized like eco if a certain percentage of the companies go for eco industrial symbiosis. Symbiosis means waste from one become material and source for the other, and that includes wastewater. And that is a very important driving force, and Vietnam is working on that now. And the other, I don't want to take more time, but very important issues after, you know, something behind. I think we have in this meeting Mr. Hai. Mr. Fahai is very good in wastewater treatment, and he has very good example he can tell us in Nam Định province, where textile wastewater is reused after his membrane technology. Mr. Hai can give us some figures. Yeah. This is to illustrate the Professor Wagner's presentation. Thank you.
Okay.
Thank you, Professor. Thank you. Thank you very much for your very interesting comments. Yes. So.
Yeah, Mr. Hai, if you have any comment.
Yes. I just had one question about Saudi. You know, the Vietnamese, the requirement for effluent standard, Saudi is very high, very strictly. For the level A, about 500 ppm something, level A. And you know, as you know, most the industrial zone are located in the upstream area. I mean the Dong Nai or Bình Dương province. So standard for south very strictly. If the south is strictly the chance for water reuse is very hard, because you know, I am the engineering company. We treat the wastewater very clean, very clean. However, Saudi cannot remove. And if we continue to treat by RO technology, I mean reverse osmosis something, so we disrupt the south. So that means we cannot reuse the clear water anywhere. So lucky for me, the Nam Định project, the factory located in the industrial park, and that industrial park is have the sound limitation very high, about 1,000, above 1,000. So that's when we had a chance to reuse water, and that's I think we should think about the policy, the government policy, to think about the south. This is very important. Otherwise, we cannot reuse the water in Vietnam. I think so. That is my idea. I just thought you do some the research. What the south effect on the environment, something, and you say to the government, people say thinking about that. That's it. We think about that. We talk them about the south. That's all. That's my question. Yeah.
Okay. Yeah. Thank you very much. That's very interesting, and
yes,
I hope that your government will work on that in future, so that you will have not so much problems. But I want to give one more comment or one word to the future students. So young boys and young girls, you see how interesting the topic is. What we discuss now, yes? We discuss about water. That is essential for your country in future, the quality of the water. And when you study water technology at universities, for example, in the master courses, you learn a lot of water treatment and in details, yes? I can speak in very detail about treating especially water or wastewater. I don't do it. That you will learn when you study it, yes? But I want to show you how interesting all the topics are we discuss here. And you see my colleagues from Vietnam, they are very experienced, yes? And I hope that you, when you are ready with your studies, you are also so experienced. Thank you. That was only a comment to students. Thank you.
Yeah. Okay. Thank you, Professor Wagner. Okay. Professor Việt Anh and Mr. Hải. Right. Okay.
Yeah.
Yeah. And Dr. Tuấn also. So the next question, please. Professor Thanh, where are you? And also Professor Quân. Okay. Professor Thanh, you have any question? You can unmute yourself.
So to save time, I just want to ask one more questions.
Yeah.
Dr. Wagner. Currently, I have observed several cases, especially the contamination in the wastewater. So normally we deal with the problem. For example, in Vietnam, when we have a kind of septic tank, normally as a septic tank, people have every house they have a septic tank, but these days they use a lot of antiseptic detergent, so nitrification is not happening well, and at the septic tank. So when it end up in the wastewater treatment plant, so the law regulation is just concerning only ammonia, but they don't care about nitrate and nitrite. So, but the nitrate and nitrite is the contaminant, so it can cause a kind of eutrophication and many other problems. So when they apply nitrate and nitrite for irrigation or watering the plant, we have problem. We have problem. That's kind of become a runoff water. That's kind of water become problem. So if we apply that kind of reuse of industrial after treatment wastewater, we might create a problem of eutrophication for example, in Vietnam because of nitrate and nitrite. And the government is care only about ammonia, not care about nitrate and nitrite. Yeah. So in such a case, what could you suggest to our government to change that kind of regulation so that could improving the case? Can you?
I only can speak as a researcher in the field of wastewater technology. Your government has to decide, not me. But I understand the problems, yes, and I know it from my research projects. That is a problem to have septic tanks, yes, and I see it in China. They take out all the septic tank out of operation and send the wastewater from the houses, for example, directly to the sewer. And say that could be a solution. But you, as researchers in Vietnam, you have to bring it to your government.
Little more. The problem here is because we use a detergent or use a kind of hand washer, but normally they put a kind of nano silver and many kind of disinfectant, we would say. So at a septic tank, so that's kind of create a problem with the nitrification. So
I understand. I understand the problem, Mr. Duan, but yes, I can't solve it. Yes, you have to solve it.
Yeah.
Thank you, Professor. Yeah.
In this case, we should remove the nitrogen. It's better that we remove the nitrogen to reduce the nitrification.
Yes, Dr. Liu, very short. As you know, I have to leave the meeting now because of other meetings. I want to thank you all the participants to be with me and with my presentation. And I hope I will see you personally in near future, hopefully. I want to travel to Vietnam, such a very nice country, and I hope to see you in good health.
Okay, hope to see you next year, right? Okay.
Thank you, sir. Thank you very much.
Thank you, Mr. Matna.
Thank you
If you
very
have
much.
any question, you can send it to me. Also, that
thank you. Thank you very much.
To Professor Wagner.
Yeah, thank you very much, Professor.
Thank you very much. Bye bye.
Bye bye.
Thank you very much for your audience today. Okay. Yeah.
All right.
And see you again.
Anh.
Yeah.
Được nha.
Yeah.
Không kịp hất điệu. Sao? Lại nãy giờ đang họp.
Yeah.
Mới nghe xong.
Rồi, thank you rồi bác sĩ Vân. Ok, yeah,
Vâng anh,
thank
dạ.
you for on. Yeah.